Hey, we're back again with another example of Mr. Wernau does your homework. Alright, so in our first video, we reviewed cross sections and volumes for question number 1. And we looked at the 2x and x squared. Now this was, of course, non-calculator. So let's take a look at a calculator example. For question number 3, they're giving us the region between f and g, where f is this 1 plus 2 sine of x, and g is e to the x over 2. And we want to find the region between, in the first quadrant, enclosed by the two graphs. And they're showing the figure below. I didn't give you the figure, but we know what they're giving us a calculator, so we can go and do that. Now, you can always tell calculator questions just by looking at knowing how ugly they are. They're not going to make you solve one of these by hand. So let's take a look here. So the first thing I'm going to do is, of course, clear my memory, Doc B, so we don't have all the answers there. And I'm going to go ahead and graph my two functions. The first one, y equals 1 plus sine of 2x. Now again, as always, make sure you are in radian mode, especially for calculus BC here. Sine 2x, dos X's. Stay nerdy, my friends. And this is a pretty ugly looking function right there. And then we're going to graph our excellent friend, e. So we're going to go tab, and that's going to be e to the x over 2. And again, if you're using the online calculator, it works just the same. We get x divided by 2. I press enter. And now notice, we're looking for it did tell us the area in the first quadrant. So we're only looking at quadrant 1. So we're not looking for, look at all that. It'd be really kind of hard to do. So they're only looking for this like little eyeball of a problem. And I'm going to draw that. It's not going to be any good, but remember, it's only for me anyways. So my first one, there's my sine curve. It kind of goes like this. There's my f. There's f. Okay, there's the looking arrow. There's f. And then I'm going to draw g. Well, g, of course, is that exponential graph right there. And g comes up like this. There's g. All right. So the region we're looking at is, of course, the part in between. So I'm going to go ahead and shade it in and sing my shady song. I'm Slim Shady, I'm the Slim Shady, all you other Slim Shadies are just imitating. There we go. So I shaded it. So for part A, so let's take a look at part A. And for part A it says, find the area of R. So we're looking at the area. Now again, we are in terms of X, which is nice because we don't have to switch any of our variables around. Remember what we did up here? We had to switch our variables around up here. So we are in terms of X, so we don't have to switch any variables, and therefore this is going to tell me to do a horizontal rectangle because I'm in terms of X. So if I was looking for the area, I'm looking at my horizontal rectangle right there. And of course, I'm going to blow up that rectangle. So there's my rectangle. Remember, the skinny part is the d whatever we're in terms of, dx. That's the skinny part. Makes it really easy for you. Up over here, again, it's going to be top minus the bottom. I'm looking for area. Pretty easy. My top function is f. And I'm going to put that in parentheses, 1 plus sine 2x minus the bottom, which is what up, g, e to the x over 2. And I can find the area of this rectangle pretty easily. It's going to be the length, let's call that the length, and not the width, right? Whoops, that's a weird looking W. There we go, length and width. So I can just write this as 1 plus sine 2x minus e to the x over 2. There's my length, dx. I couldn't simplify it, so there it is. And now that's going to find me, remember, the area for just that little tiny rectangle, which is essentially 0. dx is so small, remember, that's essentially 0. But we're going to add up an infinite number of zeros, and we're going to get something out of it. And to do that, that's where we have the integral. That's that super sum. So the last thing we have to find, of course, is the intersection. Now, it looks like 0, but I'm not quite sure, so I'm going to use my ever-trusty calculator to help me find the intersections here. Where they meet. So I can go to Menu, Analyze Graph, whoops, 6, Intersection 4, and I'm going to scroll, and I hit, hold on, no, something's, there we go. My calculator's having a heart attack, it looks like here. There we go, hit Enter. And I'm going to just scroll to where they meet. Okay, what's going on here? Come on, you can do it. Alright. Something's going on. And if I just keep scrolling, don't do it again. It does give me x equals 0. So there is one of my intersections, and let's see if I can scroll over to get the other one. Oops, it's not giving me the other one, so I just hit escape and I just do it all again. Hopefully it'll be a little bit faster this time, right? I'm slowed down only by the technology. Hit enter here, lower bound, upper bound. Who's the bound in the middle? And it looks to be about 1.24. And the student taught me a neat little trick. If I just press enter here, and I just hover over the point, the x-coordinate, because I want to go about 3 decimal places. If I hover over the x-coordinate and just hit the plus sign, it goes a little further. And so now if I just move away, now instead of 1.4, it looks about 1.136, and that's what I'm going to use. 1.136. And I'm just going to type those in. 0 to 1.136. Go to my home screen, homies. Ready? Home screen. And I go menu 4. Now remember, if you're using the online or the CX, instead of being number 3, it'll be number 2. So I just say I have to 3 because I'm using a gas. 0 to 1.136. And I just type in my function. Again, make sure you're in radian mode. 1 plus sine 2x. Get out of that parenthesis, be careful. Minus e to the x over 2. Don't forget your differential. Press enter. And we're going to get 0.429. And that would be the area of that little region. Alright. Now part B, let's take a look at part B. Part B says the region of R is the base of a solid. For the solid, the cross sections are perpendicular to the x-axis. Again, we like that so we don't teach any variables. Are semicircles. We don't like that because that's a little bit more math for us. Find the volume of the solid. Alright, oops, let me go ahead and erase all of this. Okay, didn't know we can read through all of that. There we go. Oh, that looks so much pretty. There we go. Alright, so now what they're saying is that this region right here, we have little semicircles coming up. So I'm going to draw my cross section, which is a semicircle. I'm going to draw it out. There's my cross section. Now remember, that's my thickness, dx. Because remember, we're taking this rectangle of mathematics, we're laying on a side, and we're building a semicircle on it. This is the base. This is the base of my cross section. Right up there. So we know its length, and we know its length is going to be this 1 plus the sine 2x minus e to the x over 2. Now remember, this is the entire length. So that's the diameter. We know to get the area of the base is 1/2 pi r squared. So what we need is the radius. So to get the radius, I just take half of that. It's ugly, but you know, that's why we're using a calculator on this one. E to the e to the x. You know what? I'm just going to erase it, hopefully. E to the x over 2. So to get my volume, it's going to be the area of the base times our height. Remember the height, that's our secret. That's just dx, or dx in this case. Yeah, there we go. So the area of the base, that's our semicircle. Very easy to do. So my volume is going to be 1/2 pi times the radius squared. So that's going to be this 1/2, 1 plus sine 2x minus e to the x over 2 squared dx. Now I do have a choice right here. I could at this point set up my integral and solve it. I could use a little bit of algebra too. If I square the 1/2, I can factor that out. That becomes 1/4, and that's going to give me 1/8 pi, and then I can write my integral for the rest of it. It's not much easier. Don't forget the square though, dx, but it is one less thing you have to type in. And my domain, again, is going to go from 0 to this 1.136. 0 to 1.136. And let's go ahead and type that in our trusty calculator of mathematics. We're going to go menu for, remember, if you have the CX, you'll be pressing 2, that's your integral. I have to press 3 for my integral. 0 to 1.136. I'm going to type all of this in, parenthesis, 1 plus sine 2x minus e to the x over 2. Don't forget, we got to square that, and then you get your dx. I press enter. Now don't forget, we're not done yet. We still got to multiply that by 1/8 pi. So now I'm going to multiply that by pi. You never know where pi is. I just type it in. That's not even multiplying. Oops, escape. Times pi. And then divide that by 8. And that's going to give us 0.078 for our volume. Not a very big volume. Alright, so I hope you enjoyed the video. I'll see you guys later. Bye-bye.